Hello everyone. In this video, we will solve questions of activity 11.2. Let x follows binomial n comma p and x has the following CDF. Okay. So the question number 1 is find the value of n. So here it is given that x is following the binomial n comma p. So if x follows binomial n comma p, then the range of x is 0, 1, 2 and it goes up to n. So the maximum value that x can take is n. So from the given CDF we can see that here the x is taking value starting from 0, 1, 2, 3, 4 and it going up to 5. Okay. So here x belongs to 0, 1, 2, 3, 4 and 5. So we can see that value of n should be equal to 5. Also we can see that we know that the formula of CDF fx is equal to probability that x is less than or equal to small x, right? And here fx is given as 1 when x is greater than or equal to 5. So from the given CDF we can see this thing. Okay, so CDF of x, which is probability of x is less than or equal to x, we can write it like this also. Okay, now from this line we can write that probability of x is less than equal to 5, it should be equal to 1, right? So here we can conclude that x can take values from 0 to 5. Okay, so the maximum value that x can take will be 5. Okay, so the value of n will be 5. Question number 2, find the value of p. So here we are given that x is following binomial distribution with parameter n comma p. Okay, so x is following binomial n comma p and we have already calculated the value of n, which is equal to 5. Okay, now we know that the formula of CDF is fx is equal to probability x is less than or equal to x. Okay, so if we have to find the CDF at point 0, it will be equal to probability x is less than or equal to 0. Okay, now from the given CDF we can see that when x is less than 0, it is equal to 0, and when x is greater than or equal to 0, then it is 1024 divided by 3125. So we can write it that probability x is equal to 0 plus probability uh, x is less than 0 and probability x is equal to 0. So when it is less than 0, it is 0, and when x is probability x is 0, okay, when x is equal to 0, then it is 1024 divided by 3125. So we can write 1024 divided by 3125. Okay, so suppose this is our equation number 1. Now we can also write it f0 as equal to probability x is less than 0 plus probability x is equal to 0. So this value is 0, and here we can use the formula of binomial distribution, PMF of binomial distribution. So here it will be n c0 p to the power 0 1 minus p to the power n minus 0, right? So it will be 1 minus p to the power n. Okay, so n is given as 5 here. So from equation number 1 and from equation number 2, we can write that 1 minus p to the power 5, it is equal to 1024 divided by 3125. Okay, so 1 minus p, it will be equal to 1024 divided by 3125 whole power 1 by 5. Now here we can find out the value of p. So 1 minus p will be 4 divided by 5. So value of p, it will be equal to 1 divided by 5. Okay, so which is 0.2. Question number 3, find the value of q. So we have already calculated for this question that the value of p is equal to 0.2, and we know that q is equal to 1 minus p. So q will be 1 minus 0.2. So value of q will be equal to 0.8. Question number 4, Find the value of probability x is greater than or equal to 3. So we can write it like 1 minus probability x is less than 3. Okay, so here x is following binomial distribution. So x will be a discrete random variable. Okay, so we can write it like x is less than or equal to 2. So probability x is less than or equal to 2. It is nothing but the CDF at point 2. So from the given CDF, we can say that when x is less than or equal to 2, the value of CDF is 2944 divided by 3125. So it is 2944 divided by 3125, which is equal to 181 divided by 3125. Hence the probability that x is greater than or equal to 3, it will be equal to 0.057.